A squid the size of a walnut hunts in open, moonlit water with no shell, no ink deployed, no darkness to hide in. The predators below it simply do not see it. Its name is Euprymna scolopes, the Hawaiian bobtail squid, soft-bodied, slow, and completely exposed in the shallows off Oahu. No armor, no speed, no cover. The animal it fears most hunts from below. A flagtail fish, Culia sandvichensis, holds position near the sea floor and tilts its eyes upward. It scans silhouettes against the moonlit surface. Any object between the fish and the light becomes a dark shape, a target. The bobtail squid should be an easy target. It is smaller than your thumb. It moves through open water at mid-column. From below, its body should cast a shadow, a clear, dark outline against faint silver light. It doesn't. The fish looks directly up at the squid's position. Nothing registers. The squid passes through the visual field of a predator built specifically to detect exactly this kind of prey, and it registers as empty water. This is not camouflage in any conventional sense. The squid has no dark patterning on its underside. It produces no ink cloud. It does not press against rock or coral. It does not change color to match the water column. Something else is happening. Something that comes from inside the animal itself. Not pigment, not refraction, not behavior. In 1984, Edward Ruby at the University of Wisconsin-Madison published evidence pointing directly at the mechanism. What he found inside the squid's body was not an organ in any traditional sense. It was something living. Something the squid did not inherit, did not grow from its own cells, and cannot survive without. By the end of this record, the exact mechanism the squid uses to vanish will be filed in full. So will the reason it must destroy most of that mechanism every single morning. What Ruby found in 1984 was only the beginning. The stranger part is what happens at dawn. The obvious answer writes itself. Bioluminescence is a chemical reaction. An animal produces it the way a firefly does. Luciferin meets luciferase. Electrons shift. Light exits. Clean, internal. Controlled entirely by the organism. That is the model everyone reaches for first. For most bioluminescent animals, it holds. When researchers in the early 1980s began mapping the bobtail squid's light organ, the assumption was already in place. The organ exists. The light comes from the organ. The squid makes the light. 3 steps. Obvious. Filed. Edward Ruby at the University of Southern California had cultured the squid bacteria pairing in a laboratory setting by 1977. But the dominant interpretation was still that the bacteria were secondary, passengers. The organ itself, the squid's own tissue, seemed like the logical engine. Then someone removed the bacteria entirely. Researchers raised Euprymna scolopes hatchlings in sealed, sterilized seawater. No sediment, no ambient ocean microbes, completely sterile conditions. The light organs developed on schedule. The tissue formed correctly. The structure was intact. No light, ever. 72 hours in a sterile tank. The organ sat there, pale, anatomically complete, and absolutely dark. Not dim, not faint, dark. The squid's own tissue produced nothing. Ruby and McFall-Ngai pushed further. When they scanned the bobtail squid genome for luciferase genes, the specific genetic machinery that produces bioluminescence, the locus was absent. The squid carries no copy of that gene. Not a degraded version, not a silenced remnant, nothing. The squid cannot make light. It has never been able to make light. The organ is real. The glow is real. But the squid's own biology is chemically, completely dark. If the light isn't coming from the squid, then something else is living inside that organ, something the squid has to find. And the question that stopped researchers cold in 1984 was this: how does a newly hatched squid, smaller than a fingernail, locate the exact right organism in an ocean full of the wrong ones? Here is the mechanism, not a chemical stored in a gland, not a pigment switched on at dusk, a living colony recruited fresh every single night from open ocean water. The bobtail squid hatches bacteria-free. Its light organ is already built: crypts, reflector, lens, chromatophore shutter, but dark, empty. Spencer Nyholm, at the University of Connecticut, documented in 2004 exactly what happens next. The organ secretes mucus, chemical gradients pulse outward, ciliated ducts open. And from seawater containing thousands of bacterial species, only one passes through. Vibrio, fischeri. Every other species is turned away. Within hours, the crypts fill, the bacteria multiply. By hour 12, density reaches 10 to the 11th cells per milliliter. The organ lights. Then the squid does something remarkable. A reflective backing layer redirects the light downward. A lens focuses it. The chromatophore layer, those contracting pigment cells, acts as a living dimmer. Edward Ruby and Margaret McFall-Ngai quantified this in 1991. The ventral output matches downwelling moonlight intensity to within the detection threshold of any predator below. The shadow disappears. Not hidden, replaced. A fish looking up sees only more light where the squid should be. The squid is not invisible. It is indistinguishable from the water itself. But here is what nobody expected. At dawn, the squid vents. McFall-Ngai and Ruby documented it in cell 1994. 90 to 95% of the bacterial colony is expelled from the light organ every single morning. The crypts drop from 10 to the 11th cells per milliliter to near zero. Not a die-off, a deliberate purge, synchronized to sunrise. Every adult night of its life, the squid rebuilds from scratch. Why? Science has not closed this question. Hypotheses exist. Population control, genetic quality filtering, metabolic reset. None are confirmed. The promise at the start was a walnut-sized animal vanishing in open moonlit water, with no shell, no ink, no darkness. What you have instead is a squid farming living light, tuning it to the sky, and then destroying most of it before breakfast. The bobtail squid does not possess bioluminescence. It manages it, nightly, the way a farmer manages a crop, and the fact that it burns 95% of that crop at dawn, every dawn, remains one of the genuinely unresolved questions in symbiotic biology.